Hello everyone, welcome to Learn Overflow. In this video, we'll discuss another LeetCode problem that is the set mismatch. This is an easy level problem and we'll understand how you can solve this question easily and finding a better approach to solve this kind of question. Fine. So before moving on, if you haven't subscribed to this channel, make sure to subscribe to Learn Overflow for regular LeetCode videos like this. The question says we are given a set of integers s. So there's a set of integers are given to us, which originally contains all the numbers from 1 to n. This is important. So this set given to us contains all the numbers from 1 to n. Okay, but unfortunately, due to some error, one of the numbers in s got duplicated to another number in the set, which results in the repetition of one number and loss of another number. Fine. Now, what we need to do, we are given the integer array nums represent the data status of the set after the error. So here the nums is given to us and it contains the error where one number got duplicated and another number which is supposed to be there got lost. Okay. So in that case, we need to find the number that occurs twice. So first task is we need to find the number that is being duplicated and the number that is missing. That's also important. So not only we need to find the duplicated number, but also the number that is missing and ultimately return them in the form of an array. And our main task is to we need to return them in the form of an array. Fine. So few important things. First thing is it's from 1 to n. Okay, the numbers are there in 1 to n. One number got repeated. Okay, there's a repetition of one number and the loss of another number. That's important. What our task is, we need to find both of this number. Fine. Now that's the whole idea for us. So if you just look in this example, it's like 1, 2, 2, 4. So you can see like 2 gets repeated twice. So the first number is the number that is repeated twice. And the number which is missing is like 3 is missing. Fine. So it's like the 3. Okay, the next number. That's the missing number. Fine. So that's how they're asking us to do. But there's a problem with this example is they may not give you this array. They may not give you this in a sorted format. Right? This may not be there in the sorted. Nowhere they have said that it's sorted. So first task you can go ahead is like simply sort this array. Okay, it's approach one. There will be multiple approaches which I will discuss, but it's the approach one. So you can sort this array, and then if you find two numbers getting repeated, that means like if a current number is equal to a last number, that means that there's a repetition, and you got your first integer, that's a duplicate, and whatever be the duplicate, that's duplicate plus one will be the one that's missing. This is possible only when you have sorted the array. Fine. So once you have sorted the array, then you have got an approach that you can do it. Now, remember sorting array, that is arrays.sort, would take you n log n time. Fine. Now, without sorting, what is the basic approach? Like the simple brute force approach would be like you going ahead from 1 to n, like you move from 1 till n, like equal to n. Okay, that's a loop of I. Okay, consider like this, and you are taking another loop from this numbers. Okay, and you are checking whether I is equal to this number or not. So what would be your case? And you're counting like how many times this I is getting equal. So in that case, what will happen? This count is usually be 1 in most of the cases. Right? In one case, the count will be 2. In another case, the count will be 0. Okay. So this wherever the count is 2 is your duplicate number. Wherever your count is 0 is your missing number. So that's an order of n square solution, because on one hand you are traversing through the whole I, like the 1 to n, checking for each of the digit and finding out whether there's a count is there or not. Fine. And at the same time, within that, in another loop, we are traversing the whole array to just find a match. Okay, find a count of that. Now, once you can do this, so it's more or less after the solution, it's clear that more or less we have to keep a count of this, right? So we somehow need to keep a count of this. So what can be our solution if we look for our collections framework? Okay, so you remember we can map our solution. Usually what we do is whatever the integer in we are coming across, okay, we map that to its count in a map to its count. Whatever we count, we'll map that. So we'll keep on increasing the count. And if anywhere, if a count is getting 2, fine. If anywhere the count is getting 2, then we should get it like if anyhow the count is getting 2, then it's like duplicate. If another count is getting 0, that's the missing number. So that's one way. Remember? So what we first of all what we did, we went ahead with the order of n square solution. That's a brute force. But from that we find out that we actually need to find this duplicate and the missing by checking for the count. And how can we do that? We can use that using storing that value in a map. Fine. In a map, you store that value based on the number and the count of that number. Okay, and that's the order of n first level. Like you are storing them, and then you are taking another order of n loop. That's a different loop. So in that, you are just checking if map contains this particular key, that particular value. You are taking I equal to 1 to n. That's another order of n, and you are checking if this map contains this key. Then we're checking for the value, like the count is there, so is a value. So if the value is 2, you got your duplicate value. And if the map doesn't contain a particular key while traversing from 1 to n, then you got your missing number. That's a bit improved solution. Why? From going from order of n square in brute force approach, you came down to order of n in this using this map. But can you improve it further? Like, can you improve it? It's like you cannot go beyond order of n, obviously. But what can be an improvement you can do is like increasing the total time taken, because again and again hitting a map is like it takes some time, right? But you can improve it using an additional array that increases your space complexity but ultimately decreases your total runtime. How is it so? Your approach will be first of all you take another array. Okay, here you got order of n this nums array. Okay, and additionally you take another array, and in that whatever be the key or whatever be the value in the nums array, you increase its value in the at that position, like at that index of a new array. Okay, at that index you increase its count, right? And then you simply traverse through the whole array of this in our new array, and in that once you find that any value is 2, like anywhere the value is 2, you found your value, like you found your duplicate number. And anywhere you found the value is 0, fine, anywhere found the value is 0, you found your missing number, right? So how is it improving? See, hitting a map or sorry, hitting an array is coming up close to order of 1, right? You just checking for its index. So in that way, our time complexity is not getting improved, but our total time taken, because hitting a map, then getting its value and updating its value again and again was a huge task for us for previous class. That was not increasing our total time complexity, but it is increasing the total time taken. Okay, over here also, if you want to find a faster solution, both of this takes order of n. Okay, because you are traversing through the whole array. You're traversing the whole map, or you're traversing the whole array. Anyways, it takes order of n complexity. Anyways, it takes order of n as your space complexity also. Fine, but what happens is in this case, your total like the finding the like the incrementing the values in the array or adding the values in the array becomes faster. Obviously, uh, this is also fast, but arrays you can see like we find the value, like in map what we get map dot contains key is once we find that whether the key is there, then we find map dot get. Okay, but in array what we are doing, array of I, that's easily getting the particular index and returning us the value. So that's how it becomes a bit faster. So let's quickly write a solution based on this. Okay, and also if you make sure to check down the description, you will find a link for this code. There you will find the solution based on this map as well. Fine, so that's also will be there. So let's quickly write a solution based on this particular array based solution. Okay, this is a 4 millisecond solution. Obviously, it can go down, but let's not think of it. Let's say what exactly we did. We first of all taken another array that is nums.length plus 1, because we are not making it 0 index, we're making it kind of indexing for 1. Okay, so what happened for each of the values in our nums array, we just made the count like x of I plus plus. We're just, whatever the index is, we're just incrementing the value. So why we take nums.length plus 1 is because of this. We are not making I minus 1, because I will be pointing from 1 to n, right? But so that's why we're just making I plus 1. Now what happens is, like, we took two other variables, duplicate and miss. So one will be storing our duplicate value, and the other will be storing our missing value. Now what is there is, like, I like 0, like 1 till length dot x. Okay, like x dot length. And in that we find that if anywhere the value is 2, we just make it a duplicate. We find the duplicate, and anywhere the value is 0, we find it a missing. Now we can make a bit improvement in that. What improvement is, like, if after some iteration we find that the duplicate and missing is not 0, both are not 0, that means we have already found, and there's no need further to traverse this loop, right? So once that is the case, we can break it. So that's a bit improvement you can come across over here. So let's say so it's not like it should make a difference, but based on the runtime, it's not making further difference. So it's like 4 ms only. So I hope you can understand the solution and how you can find a solution based on this. So thank you for watching this video. Make sure to like this video and subscribe to the channel for regular LeetCode videos like this. Hope to see you soon in my next video as well. So thank you all for watching this video. Thank you.